Hey everyone, let's take a look at a problem in 3 dimensions, similar to what we just did in a previous video. I'm not going to worry about the sum of the forces equaling 0. I just want to look at how I find one force. I might need 3 or 4, but let's just look at how I find one force based on the position vectors along, let's say, a cable. So let's assume I've got some sort of a beam sticking out from the origin here, and I'm going to have the beam in the XZ plane. Right, and it's going to have an angle of 36.9 degrees with respect to the positive x-axis. And so that means it's a 5-foot long beam, so it's going to be 4 feet in the x and 3 feet in the y. It doesn't matter what's going on here at the origin as far as how that's being held in place. Let's just say there's a beam in the XZ plane of 5 feet length, 36.9 degrees. So if I do that, then the position, I'm going to designate the position at the end of the beam as A. Then that position is 4i, 0j, because it's in the xz plane, plus 3k, and that's all in feet, right? Because the displacement or length vector there, so it's going to have units of feet. And then there's another beam parallel to the x-axis, and it's 7 feet up. And this beam is going to have a length of 2 feet, right? That's not shown on there, but this would have a length of 2 feet, okay? So that beam is along the x-axis, so it's going to have a position B at the end, and that position B is 2i, so 2 feet in the x direction, 7 feet in the y direction, because it's up 7 feet along the y-axis, and then it's not in the k direction at all, right? Because it's along the x-axis and on the y-axis, it has no z value to it. So what I'm interested in then is I'm going to have a chord go from position A to position B, and it's going to have some tension, which I'm going to designate as TAB, the tension from A to B. Right, so let's label that, the tension from A to B. Of course, there could be the same tension from B to A. It doesn't matter. I'm just going to designate from A to B. So what I'm interested in then is the displacement vector from A to B. In order to do that, I take the B position and I subtract the A position. Right, going from A to B, it's position B minus position A. And so that's going to be, in the x direction, it's B minus A, so it's 2i, and then I'm going to subtract from over here 4i. So 2i at B minus 4i at A is negative 2i. Right, so there's negative 2i, and that's going to be in feet, which I'm putting out here at the end. And then 7j minus 0j, because there is no j component down here. So 7 minus 0 is simply 7. And then 0k, because up here it's along the x-axis, 0k, and then subtract from that 3k, and that gives me a negative 3k. And so RAB, R from A to B, is this right in here. Right? But what I'm interested in, because I want to know the tension, I'm interested in the unit vector. So what I'm going to do is I'm going to take RAB, I want RAB unit vector, so I take RAB, which is in feet, and then I divide by the magnitude of that. Well, I use the Pythagorean theorem, but in 3 dimensions. So it's the x quantity squared, so negative 2 feet, square that. 7 feet, that's the y quantity, square that. And then negative 3 feet is the the k quantity, square that. Of course, when you square, all the negatives go away. So I'm going to get 4 plus 49, right? 4 plus 49, that's 53, plus 9, that's 62. And then feet squared, feet squared, feet squared. So I get 62 feet squared, but I'm going to take the square root of that. So my numerator is negative 2i plus 7j minus 3k, right? That's the numerator, and that's in feet. And then I'm going to divide by the square root of 62 feet squared. But when I take the square root of feet squared, I get feet. And so I have feet up here, feet down there, because it's the square root of feet squared, and that goes away. So there's no units. And so this, inside the parentheses, becomes my unit vector. No feet, right? There's no length in here. This is simply a unit vector pointing from A to B. So it's a vector pointing from A to B with a length of 1. And then this is what I get in the decimal format for that unit vector. And so the tension as a vector quantity would be this unit vector times the magnitude of the tension. I might not know that magnitude, or then again, I might. But this could be one of several different tensions in a problem. And then you would do, if it's an equilibrium problem, you do the sum of the forces in the x, y, and z. And then you'd have probably 3 equations and 3 unknowns. Later on, when we talk about moments, we could have a lot more unknowns, right? But this is going to be 3 equations, 3 unknowns. All right, so there's just a tension in 3 dimensions using the unit vector. If you have any questions, please leave them in the comments below. Thank you.